Hello! Today we are going to work with negative exponents. So if you remember from last week, we worked with multiplying and dividing and power to power with same and different bases, but all of our exponents were positive. So let's look and see, how do we find the value and how do we deal with negative exponents? So this first problem, we have 3 to the negative second. Now, how would we get a negative exponent? Well, think about what we learned with dividing with exponents. If I have 3 to the third divided by 3 to the fifth, remember when I have the same bases, to simplify, I'm going to keep my base, and when I'm dividing, I subtract my exponents. So this would be 3 minus 5, which would give me negative 2. So that's number one, how I would end up getting a negative exponent. Well, let's see, how do we find that value? What does that mean? So to break it down, this is what it would look like. 3 to the third power, my numerator would have 3 threes. 3 times 3 times 3. My denominator would have 5 threes. 3 to the fifth power. Okay, now let's simplify those like we did last week. Any number divided by itself is 1 and they cancel out. So these 3's could cancel out, these 3's, and these 3's. That leaves nothing on the top, and we do have 2 3's on the bottom. Even though we don't have 3's on the top, think about when we divide a number by itself, it gives us 1. So every single time up here when we're dividing 3 and we're canceling out 3 divided by 3, it gives us 1. So our 1 is on our top, and our denominator still has my 2 3's. 3 times 3. There was 2 of them that did not cancel out. Well, how can I simplify my denominator 3 times 3? Any number multiplied by itself can be expressed with an exponent. So I get 1 over 3 to the second, because 3 to the second is 3 times 3. So 3 to the negative second power, I can really, and when I walk through that and work through, gives me 1 over 3 to the second. Well, what do you notice about my original problem, my original expression of 3 to the negative second, and my simplified answer once I worked that out? This is the key point you need to copy down. When a number has a negative exponent, it can be expressed as a positive exponent in the denominator of a fraction where the numerator is 1. If you're confused again, go back and look at that previous slide to go through the steps of how we ended up with that number and with that exponent being positive in the denominator. Pause this if you need to make sure all of this is copied down. The reverse is just the opposite. So let's say I have a negative exponent in the denominator, 1 over 3 to the negative second power. Well, it's just going to be the opposite. When a number has a negative exponent in the denominator, it can be expressed as a positive in the numerator. So we really could, up here, 1 over 3 to the negative second power, I would flip it so it becomes 3 to the second power in the numerator, and the denominator would be 1. However, we know if you divide anything by 1, you're just going to get that number, which is why we would just see 3 to the second. Remember, a whole number or anything can have a denominator of 1. Pause this and make sure you write this key point down. All right, so let's work through how to simplify with negative exponents. So for this first one, I have 5 to the negative second times 5 to the third. When I see negative exponents, I want to write them as positives. So we know that here, if I have 5 to the negative second, to make it positive, I'm going to have to put it in the denominator of a fraction, 5 to the positive second. Again, we just learned 5 to the negative second, a negative exponent, can be expressed as a positive in the denominator. 5 to the third is just going to stay here. It's not going to move into the denominator of a fraction because it's positive. We'll go back to last week, our rules with dividing with like bases. I keep my base, 5 to the third divided by 5 to the second, subtract my exponents because I'm dividing, and I get 5 to the first power, which we just write as 5 because that has our exponent of invisible 1. Okay, for the second one, first thing I'm going to do if I ever see division horizontally, I'm going to rewrite it vertically. So 4 over negative 3, 4 to the negative third power over 4 to the negative 6. Now, what I need to do, since I have these two negative exponents, I'm going to need to move them to the opposite side of my fraction bar. So this 4 to the negative third, I can rewrite it as positive by putting it in the denominator. On the reverse side, since the 4 to the negative 6, the exponent is negative, I can move it up to the numerator to make it positive. So now I have 4 to the 6th power divided by 4 to the 3rd power. So when I divide, I subtract my exponent since I have like bases. 6 minus 3 is 3. So 4 to the 3rd power is my simplified answer. All right, so two things different about this problem. Number one, the question is asking for the value. So that means I need to take it a step beyond just simplifying. I actually need to find one number for my answer. The second thing I see different is that I have two operations. I have multiplication. I've got two terms in my numerator, and then I also have that division bar with a denominator. So first thing I notice is I see a negative exponent, which I need to take care of. So I'm going to circle it, 4 to the negative second. I want to rewrite it so all of my exponents are positive first. So I need to, first of all, I see that 4 to the 7th power in my numerator is not going to move. I don't move any positives ever. Now, the 4 to the negative second, to make it a positive, I bring it down to the denominator, 4 to the 2nd power, times, because I'm multiplying when I move a number down, that 4 to the 3rd power is going to stay here. It's a positive exponent. I don't move it. I'm only moving my negative exponents, and I'm moving it to the opposite side, which makes it a positive exponent. Now from here, this is what we did last week. Before I can do anything with my division, I see that I can simplify my denominator. So 4 to the 7th is going to stay in the numerator. I'm multiplying with like bases, so that means I'm going to keep my base, and since I'm multiplying, I need to add my exponents, and 2 plus 3 is 5. Now, division rules. I have like bases again, so I keep my base, and I'm going to subtract, since I'm dividing, my exponents. 7 minus 5 is 2. The question asked for the value, so I need to find the actual number for my answer, and 4 squared is 4 times 4, so my answer is 16. All right, so you find the value of just number 1. Okay, so the first thing to do is to rewrite the 7 to the negative 2nd power with a positive exponent. So again, my negative exponent can be written as a positive when I put it in the denominator. And so I don't have any other terms, my numerator is just going to be 1. If I'm finding the value, I actually need to find what the actual answer is in a number, no exponents. My 1 stays the same, and 7 squared, 7 times 7 is 49, so 1 over 49 is my answer. Okay, pause, do number 2. Okay, so the first thing I need to take care of is this negative exponent. I'm going to leave 3 to the 7th here. I now need to put 3 to the 4th power in the denominator. That'll make it my positive exponent. Here I see division with like bases, so I need to subtract my exponents. My base stays 3, 7 minus 4 is 3. Again, I'm finding the value, which means I need to do 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. Make sure you make any corrections along the way. And lastly, do that third one. You are now just simplifying. So if you remember back to the other week, anything to the 0 power is 1. So right now, this just becomes 1. And if I multiply anything by itself, or if I multiply anything by 1, I just get itself. So the numerator really is just 2 to the 2nd power. Because if I multiply it by 2 to the 0 power, I'm just multiplying by 1. So this really is 2 to the 2nd over 2 to the negative 4th. Remember, I don't like negatives right here. I need to move it up to the numerator so that it can become a positive exponent. This 2 to the 2nd is going to stay up here. I don't move my positive exponents. Now I'm going to be multiplying this by 2 to the positive 4th. I don't have anything in my denominator. Technically, I could put divided over 1, and I can have that 1 in the denominator. But we know that if you divide anything by 1, you're not going to see that divided by 1. So that's why we're just going to leave it as this. Now, I can continue because I have like bases of 2. I see that I'm multiplying, which means I need to add my exponents, and 2 plus 4 is 6. It's just asking me to simplify, so my simplified answer is 2 to the 6th power.